Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. Today, we are going to learn polymorphism and dynamic binding. Let's take the example of area. Suppose in a software system, there are some requirements to achieve area for different figures. Of course, there are kind of figures, right? Such as circle, rectangle, triangle, and so on. And of course, different figures has its own solution for achieving area. Okay. So let's assume that we are following the structure paradigm for the target system. And such a system must explicitly invoke correct version. So that means the system must provide functions for area achieving of different figures, such as area for circle, and the area for rectangle, area for triangle, and so on. Of course, when the programmers doing such kind of program, he must make sure of which function should be invoked. Is it function for circle or for rectangle, and so on. This is the structural paradigm for area problem. So let's have a look at object-oriented paradigm for the same problem. This class diagram is for the problem of area. It's designed in this way. Surely there are kind of figures such as circle, rectangle, triangle, and so on. But all of these classes, all of these figures are some kind of figure. So we can achieve another class as a superclass for them. It's called figure. And we also declare a method area inside this class figure. Well, we must admit that we cannot just get the implementation for this method area within figure. So it is quite easy to understand, right? Because we don't know which figure it is. So you cannot just get a solution for the area. So this method area can be just declared as an object. It is allowed in object-oriented languages. We can define a method as an object, and these object methods must be implemented by its subclasses. So let's say here, circle. The circle surely must implement the method area. It is possible, because circle is just some kind of exact figure. So we can get some solution for area problem. And also, it's the same with rectangle and the triangle. So we find that within this system, in different classes, we get the same method name, area. Let's say if we implement in Java, it will be something like this. We get the abstract class figure and the abstract method area. Class circle extends figure. It has its own attribute, radius, and its own implementation for method area. So this method area is not abstract anymore because it got its own implementation. And it's the same with rectangle. It has its own attributes, length, width, and its implementation for its area. In another class, let's say test. And here, we get a reference with the data type of figure, a figure. And then somewhere in the code, we get such a command, a figure.area. It is okay. There's not any problem with this code. Well, maybe you will find that at this time, when we just go through the code, we cannot tell which method area will be invoked. Because you see, in the system, there are quite some areas with the same method name, right? Surely, when the system is running and the correct version of method area will be invoked. But you cannot determine it statically. So now we come to the concept for dynamic binding. Actually, with object-oriented paradigm, design, and languages, it is not necessary to determine which method to invoke to get area. So we find that the only thing the system do is just to send message of figure.area, just we have seen here. And then the correct method will be invoked at the runtime. That means dynamically by the system. So the designer and the programmers don't need to worry about it. So since the correct method will only be invoked at the runtime, that means dynamically. So such a paradigm can also be called dynamic binding. And the method area can be applied to objects of different classes. That means there are different versions for the implementation of method area. So it's called polymorphism. Actually, when we talk about polymorphism, subclasses get the solution, get the implementation for the abstract method declared by the superclass is one of the solutions for polymorphism. Actually, when we learn some object-oriented languages such as Java, C++, and so on, we find that even within the same class, we can achieve more than one method with the same method name. It's called overloading. So actually, overloading is another achievement for polymorphism. Overriding is another solution for polymorphism. And we must also mention interface. Let's say interface in Java. Interface is another solution, another method for polymorphism. Actually, polymorphism is the advantages of Java programming or C++ programming. I mean, the advantages of object-oriented design and implementation. So once you achieve polymorphism, then surely you will get dynamic binding. Well, from the previous discussion, we can find that polymorphism and dynamic binding really give us quite some advantages because it makes things clearer and easier. Well, on the other hand, we must admit that sometimes polymorphism and the dynamic binding can also have a negative impact on maintenance. Just now we have found that the code is quite hard to understand if there are multiple possibilities for a specific method, because it's quite difficult to determine which method will be invoked at the runtime. And you get no idea when the code is not run. Okay? So surely it is really a hard job for maintenance programmers. Okay? Because it will be quite difficult to locate the bug. So in conclusion, polymorphism and dynamic binding give us both the strength and the weakness of the object-oriented paradigm. Well, so surely the designers and the programmers should try their best to avoid the weakness of object-oriented paradigm. So we can understand that design is very important for object-oriented paradigm. So good design will get the most strength from object-oriented paradigm. On the other hand, maybe the designer and developers will also get some problems from it. Well, okay, so much for polymorphism and dynamic binding. Thank you.